All right, I'm Ron Zarowski. I'm the state geologist and director of the Tennessee Division of Geology. As geologists, the rock layers we look at are they're like a book. The layers are like pages in a book. They can tell us a lot about what was going on millions and millions of years ago. The oldest rocks in Tennessee are about 1 billion years old over in East Tennessee near the Great Smoky Mountains. Those are mostly the volcanics, the very, very old, what we call igneous and metamorphic rocks. Here we're dealing primarily with sedimentary rocks. And originally, in this area, about 500 million years ago, these rocks were being laid down in a shallow tropical sea. The Lebanon limestone we'll be looking at was formed again in a relatively shallow tropical sea. We know it was shallow enough that sunlight was able to penetrate to the bottom so that algae in particular could photosynthesize, providing food for all the other critters that happen to live. During this period, most of the animals had hard shells that were made out of calcium carbonate, which is the same material that the rock is made of. In fact, some of this rock, the majority of the rock is actually made up of fossil shells. And so about 430 million years ago, the sea began to disappear, and this area went under some pressure from the east, and it was actually uplifted and bent into a structure that looks something like this, an anticline or a domal type feature. Then about 350 million years ago, this area went back down below sea level, and you actually had some erosion, so you had a level top across here that actually cut across these beds that are dipping or inclined. You had another shallow sea come in and start depositing materials on top of it again in horizontal layers. Then about 230 million years ago, we had a very intense mountain building episode to the east where this area was uplifted again. There was a lot of, quite a bit of volcanic activity over toward to the Smoky Mountain area. And this area then was uplifted once again above sea level where it started to erode. Now this uplift, you're talking about rocks that are very, very brittle. And brittle rocks do not bend very well at all. They break. And because of this pressure, you got a series of cracks or fractures that developed in the top of these rocks. And then once this area was uplifted, that allowed water to start penetrating into the subsurface. Rainwater is slightly acidic, and it will dissolve limestone. And so the center of the structure started eroding away much more quickly than the sides. And so we have basically a basin that's superimposed on a dome. And so this Middle Tennessee area is like a big bowl. And the older rocks are actually exposed in the center of it with younger rocks around to the sides. And then this has been going on basically for the last couple hundred million years, gradually working its way down through erosion. With all of this fracturing that was going on and all this, the solution of the limestones, there has developed in this area in particular and other parts of Tennessee and around the world a very, very extensive series of caves and sinkholes that develop along these fractures. As the rainwater percolates into the ground, it dissolves the rock out, enlarges the fractures. Things like Jackson Cave down here, which some of you may see. There's also a number of other caves in the park. Most of them are lined up in straight lines. The cracks that formed here, there's actually two sets. One that runs northeast, southwest, and then an intersecting that runs northwest, southeast. And where those intersections come together, in particular, you get an avenue for rainwater to get into the subsurface and dissolve the rock out.